To our latest online seminar, the ProSonic Flow P500. Hope you're excited about this one. It's going to be quite good. We're going to be showing you around the next chapter of ultrasonic flow measurement with the new clamp-on ProSonic Flow P500. But just before we get started, and for those that might be new to the GoToWebinar interface, I'll just give you a bit of guidelines around this. So we won't be using the webcam for the particular webinar for this one, but on the right-hand side, you'll see a bit of a dashboard where you can download some handouts and ask the questions as well that you might have during the seminar. I also got a poll for today's session, but that's a bit later, and it will be self-explanatory when it does appear. For the handouts today, we've got the first one, which is the brochure of the ProSonic Flow P500. And we also have a verification report, which I'll delve into a bit more detail further on in the presentation. But just a bit about me and who I am. So my name is Taylor McKertich. I'm the industry manager for mining and oil and gas here at Endress+Hauser Australia. I'm based in our Sydney head office, and I've been working with Endress+Hauser for over 4 years now. And I've got a bit of a background for chemical and process engineering. And our seminar today, I'm just going to go through the benefits of the ProSonic Flow P500. We'll talk about what FlowDC measurement is. We'll also discuss heartbeat technology. And for those that already know about heartbeat technology, how it applies to ultrasonic clamp-on flowmeter. What installation looks like in practice. We'll briefly cover SIL in regards with the ProSonic Flow P500. I'll give you a few generic application examples, and then we'll come to the end where it comes to the question and answer session. And I do want to thank everyone for submitting a lot of questions beforehand with this before the seminar, and I hope that I've managed to cover all of your questions as we go through. But if I've missed anything, of course, feel free to add into the questions side of your GoToWebinar interface as we go through. All right, we'll get stuck into it. And as you know, Endress+Hauser do invest a lot of funds into the R&D process for our products. And as technology has advanced over the last 15 years in particular, with our ultrasonic clamp-on meters, and in combination with the performance in the field for over 15,000 installed instruments of our previous generation, we've made the ProSonic Flow P500 into one of the most advanced ultrasonic clamp-on instruments available for non-invasive liquid flow measurement. I'm going to hit you straight up with some quick facts and the benefits of the new device. So just take a while for you to soak that in. That's up there on your screen. But really the key benefits for the ProSonic Flow P500 is that it's non-invasive. So that means you can increase your measuring reliability in bidirectional flows as well, and have greater transparency in consumption of your water. It also comes with heartbeat technology, which means you can have increased confidence in the availability and also make sure that the measuring data that you have is correct. And it also gives you improved preventive maintenance information as well, which we'll go into in a bit more detail later. It also comes with SIL 2, which means increased process safety and reliability for your operation. It comes with new coupling pads, which means these are lifetime maintenance-free clamp-on sensor installation pads. And also, we've also released it with a new frequency, 0.3 megahertz, which means we've extended the range of different frequencies available for this device, which means that we can now measure successfully on GRP or plastic pipes and pipes with very large diameters or high dampening medias. It comes with our FlowDC capability, which is measurement performance within specified accuracy, all the way down to 2 DNs of inlet and outlet runs. And it comes with a wireless LAN capability as well, which makes it really easy to install, commission, operate the device. And you can see the features of the device here with the line size from DN15 to 4000. And of course doesn't come with any wetted parts because it's a non-invasive clamp-on meter. And you can see the HMI in the picture over there as well. So what I'm going to do now is I'm just going to show on your screen what FlowDC actually is. I'll just wait for this to load. Okay, so the FlowDC function is really one of a kind, and it reduces the inlet run length to 2 DNs. And fittings such as bends in the pipe will affect the profile. And that's why you couldn't traditionally measure with significant accuracy unless you had a long straight line run length. Now this compensates with the FlowDC function, which means you can maintain the accuracy that we mentioned with up to 2 straight run lengths DN. So what prerequisites are required? In this case, we use 2 sensor pairs instead of just 1. Now the configuration depends on what type of fluid it is and the pipe diameter, but the most common installation is the 2 transverse installation as shown here, where the ultrasonic path goes through twice in the pipe. There's also a single transverse installation as well for very large pipes, and you can see this demonstrated on your screen now. Now, when the flow is disturbed, both sensor pairs measure different results, and these values are different compared to the reference value. You can see on the chart here, we're going to be plotting what these transverse paths are reading. And if you change the mounting position, let's say we move it a few degrees clockwise, and we keep doing that, and we keep plotting the measuring points on the graph here, we'll eventually find out that the mean of these measurements equal the same value. So it's the same deviation from the reference value in this specific case, which is that yellow dot line. And what the FlowDC function then does is it uses the deviation and it adds a corrected calculation factor to compensate for this deviation. And that's how it works. Now, to configure this, we just need a few bits of information from your application in particular around the disturbance type, the distance to the disturbance, and also the pipe geometry around that application. And then the device will be able to compensate for that. So in a summary, that is the ProSonic Flow P500 with DC function. I'm going to head back to the presentation now. Okay. So in line with the FlowDC capability as well, the electronics of the device have been upgraded to the latest Pro line. And this means that there is seamless system integration into your control system using the Modbus output or the 4-20 heart. We have web server access as well, which I'll show you shortly. Our HMI is much improved as well. It's much easier for you to navigate through the menus. We have a histo-ROM data storage concept, which means all the application data in the transmitter is saved, and you can swap this out when you need to replace the device, and all your settings are saved in that. We have heartbeat technology, and our life cycle management capability as well is available. Now, on heartbeat technology, I know a lot of you are probably already familiar around this concept around diagnostics, verification, and monitoring. For those that aren't familiar, it has been developed in accordance with IEC 61508 so that you can have a traceable verification of the meter if your process requires it or if your operation requires it. And the diagnostics and monitoring enable you to incorporate a preventative maintenance regime into your instrumentation. Now, the monitoring, what that actually looks like. What I've done in this example is I've used the web server for our ProSonic Flow P500, and this is a log of all the events that this particular one had. So you can see on the left-hand side of that table where it has the different symbols, they're in accordance with the Nomura standards. So it's all standardized diagnostics. You can bring all these diagnostics back to your control system as well, or you can have a look at the event log to see the history of the device and see what's happened as well. So the monitoring side is very useful if you want to troubleshoot the device and maintain it as well. It also gives some good information around the process too, depending on what type of information we're trending, and I'll get into that a bit further. For the diagnostics, so in this example, we can now get the device to tell us if it is installed correctly. And that installation status in this example, it says bad there. So it calculates this variable based on different diagnostic values, such as the signal strength and things like that. And then it creates an overall assessment of if the installation is successful or not. So it's very useful when you're commissioning. We can also trend a lot of other information, such as signal strength. So in this case, we've got a reading of 51 decibels. So if it goes below 5 decibels, there'll be a bad alarm and an indication maybe the installation is incorrect or there's process issues. We can also get the signal to noise ratio, which is the ratio between the desired ultrasonic signal and the undesired interference signals. And we can also track sound velocity in this case. And that's really useful to detect a change of the process phase or composition inside your pipe. And you can trend this over a period of time so you can monitor the changes of that process conditions as well. Some other diagnostics that you can get. There's one called the acceptance rate, which is the ratio of the number of ultrasonic signals accepted for the calculation of the flow and the number of all the signals transmitted. And you can also get an indication of the turbulence of the flow as well. So the transducer difference, the asymmetry of the device, and the turbulence, they both depend strongly on your inlet conditions and your flow velocities. So the device can now calculate a lot of those type of variables, which are really useful for diagnostics and also monitoring of the device. And finally, I spoke around the verification side. So heartbeat verification, in this case, verifies the function of the flow meter within a specified measuring tolerance with confirmed total test coverage over the useful lifetime of the device. And it complies with the requirements for measurement traceability according to ISO 9001. In this case, you can generate a PDF report, and what I did just before this seminar is generate a PDF report from the ProSonic Flow P500, and I added it as a handout on the right-hand side. So if you're interested into looking into detail what it shows, you can have a look into that one there, and then you can see all the different test coverage information. So it shows like verification information, sensor health, the electronic module test values, the IO module testing as well, some process conditions, and more as well. Finally, I did mention around seal by design. So for those that have seal requirements on site, the software is seal 3 and the hardware is seal 2 with one measurement path, or you can have seal 3 with 2 independent measuring devices. And in this case, the measurement uncertainty for those larger line sizes, plus or minus 0.5%, or the velocity is plus or minus 3 millimeters per second. And you can see the remaining areas of the measurement uncertainty there. If you're interested in more information around seal for the ProSonic Flow P500, just make sure you let me know in the survey, and we can send you a bit more details. But there is further information on that in the functional safety description manual as well on our website. I spoke around how easy it is now to install the clamp-on ultrasonic meter, and that really comes down to the use of our coupling pads. So if you haven't heard of these now, they're just simply a stick-on and a measure device where you just lock on the transducers to the coupling pads. It gives you the best signal strength over the long term. There's no contamination or aging of the gel, or there's no messy pastes that you have to apply. And because of this, you reduce your maintenance costs and your inspection on the installation site as well. So really, if you're looking at remote installations where you need a long-term solution, these coupling pads in conjunction with heartbeat technology means that you can monitor the installation from a remote location and you don't have to inspect it all the time. Now, further on around the installation recommendations, so some of you asked around if one measurement path or two measurement paths or traverses are required. So if you had a very ideal flow conditions or you had more than 15 DNs for inlet and outlet runs, then one measurement path is fine. If you would have confined spaces or not enough inlet runs available, or if you have disturbances upstream, or if you require some redundancy or additional accuracy, then we would recommend two measuring paths. For the traverses, as the FlowDC video showed, it's around one traverse would be normally for very large pipes, or if you had high dampening fluids, and two traverses if you required better flow profile recognition. It's much easier to install as well for two traverses, and most small and medium pipe sizes would use two as well. So I have an example of what a clamp-on ultrasonic meter would bring value to your operation rather than an inline meter. And this is a bit of a flow chart showing on the left-hand side what a traditional inline flow meter would go through if it was to break down in the steps that you might have to do while you're on site, while on the right-hand side, you can see the couple of easy steps that you could do with a clamp-on measurement. So with a traditional inline meter, if it was to break, you might have to raise a permit, isolate the line, drain it, make sure it is drained, cut it open or unbolt the meter itself, install the new meter, and then do everything else in reverse. And this could take a long period of time. I'm sure you guys are familiar with that. But with the clamp-on measurement, if something was to fail, even inline meter, what you could do is just get this clamp-on meter and install it with a process tool running and online and commission it as well. So this would save you a lot of time. But I'm actually curious to know how much value or how much time this would save you guys. So what I'll do is I'll launch this poll, and I'm quite curious, would a clamp-on meter save you a significant period of time in the event of a breakdown? I'll just wait to see the responses come in. We've got about a third of you voted so far. Yeah, so how much time would it save just having a clamp-on measurement rather than inline measurement? Okay, I'll wait maybe 5 more seconds. Okay, all right. So, the results are quite interesting actually. So we had a third of you almost said that it would take more than 12 hours to replace inline meter rather than a clamp-on meter. So definitely bring a lot of value if you had a clamp-on measurement. And then almost half of you, well, yeah, almost 40%, between 4 to 8 hours, and then 20% was 2 to 4 hours. No one said less than 2 hours. So that's really good to see that online. So a clamp-on measurement would really save you a lot of time when it comes to replacement of meters. Okay. So what we also said we'll do in this seminar is talk about some different applications. And with FlowDC as standard, when it comes for two measurement paths and two sensor sets, it really means that the applications are much more flexible now that you could use a clamp-on ultrasonic meter than previously in the past. So areas where you might have minimal straight inlet and outlet run conditions, like offshore platforms, pump stations, firewater stations, where you need performance within a specified accuracy, then this would be a good example for where you should use it. And it's available for lots of different industries as well. So an example here is where you can use the clamp-on measurement for produced water from ground sources. So it's important here to note that it has to be after some type of separation process. So where we have a single phase fluid, which you can measure reliably, for example, produced water, or single phase or other hydrocarbons as well, where we can measure this. So I think some of the questions were, is it possible to measure in a slurry? No, this is only for a single phase liquid measurement at this stage. This is what this meter is designed for. And then we also have some other applications over here. So examples where you have very high pressures, so inline meters become unsuitable or uneconomical as well. You can use a ultrasonic clamp-on meter here, such as injection water into a well, or some other type of high pressure water, or oil process or something like that. We find that a lot of people are also now using clamp-on ultrasonic meters for water balance accounting, where we're balancing it throughout a process or a plant or some type of area of a mine site, or maybe leakage detection as well, where you've got a large amount of transportation networks or pumping stations, or you want to replace turbine meters, or you have very large line sizes where an inline meter wouldn't be economical. This is where these type of meters would be ideal for. Another example would be water management, maybe out in the field, where you have large plastic pipes or dampening materials and line sizes as well. So now, because we have extended ranges of different frequencies, where it can cover more applications. So if you're interested in exactly what type of application will work, you can get in touch with us. Another interesting example we've come up with is that if you're draining hydrocarbon storage camps, for example, and you want to determine when there's a different phase in the process, because the meter can determine the sound velocity in one of the channels, you can see when there's a different type of liquid coming through the line. So in this example here on the chart, on the bottom left, you can see the sound, when that sound velocity changed from 1,450 meters a second to about 1,325, then you can determine that there's a different phase there, and use that for automated tank dewatering processes or some other type of process that you might have. And finally, last application we have is where it's difficult to use traditional wetted materials in inline meters. So we have an example here where a customer was using propylene chlorohydrine with hydrochloric acid, so quite a harsh application. And the piping was full titanium pipe, so it's quite expensive to cut into in this certain application. So using the clamp-on ultrasonic meter saves installation time, maintenance inspections, and also your OPEX when you're replacing a meter as well. So I hope that that short seminar covered most of what you guys were wanting to know. At the moment, I can see some questions pouring in on my side here. If you do have any questions at the moment, just type them in on the right-hand side of the GoToWebinar interface, and I'll try and get to as many as I can in the next 5 minutes. We've got a question from Lech around, are we able to measure gas flows? So no, this is only for liquids at this stage. If you're looking for gas measurement, we have inline gas meters which are capable of measuring gas. The problem with the measurement of gas is when the transducer is, if there's steel between the transducer and the material, the velocity of sound isn't very good for Yeah, sorry about that, lost connection with the server. Okay, so I was going through the questions. Okay, so are they still rated? Yes, the meter is still rated. As I mentioned before, still 3 for the hardware. If you've got 2 measurement channels as well, and also still 3 for the software too. If you're interested in the safety functional description, you can let me know afterwards in the survey. Some other questions as well. Have we got there? Okay, so how much straight line up and downstream of the instrument do you need for water? And does it change if the media changes? Okay, so 2DN, and it doesn't matter on the type of media in the process. So that can be the same. Can we measure in very small quantities? So if you want to get in touch with us and just let us know about your specific application, then we can double check with you. But smallest DN for that one is 15. So we should be able to have a type of solution for you. And I might just go into one of the other questions. What is the low flow cutoff in meters a second? Yeah, so that depends on the application as well. So if you would like to let us know your different type of application, then we can get back to you in specific purposes. Now, what you can also do as well is you can jump onto our website, and we have an applicator. So if you're interested to see what type of things are possible if you're engineering a solution, then you can jump on the applicator, which is on our website underneath the product tools. If you need help finding that, then you can just also get in touch with us and we'll be able to help you out. Okay, so for those questions that we haven't been able to get to today, I'll reply by email. I do apologize for the loss of the server connection there, and I hope you have a good rest of the week. And make sure that you fill out the survey at the end. If you are interested in a free trial with our demo device as well, we can do that, and we can arrange for one of our flow experts to come out and show you how it works, including the web server and heartbeat technology as well. Otherwise, have a great rest of the week, and I'll see you at the next seminar.